Oh, yes. Yeah. Oh, it's 514-944-6563. And let me stop sharing my screen. Because I don't think you can share yours until I. Okay, not share your screen. What? Let's see. What error does it give you? Mhm. And scroll up a little bit. Index 3 out of bounds. Okay. So go back to your code. Um, Now temp is the size. The what? And that's okay. But where is the Kyle? See if you can spot where the issue is. Index out of bounds means you exceeded where the array exists. Which line? Um, that's where it actually goes, but the problem is on line 16 because the size of your array is temp, like 3, and so it should go from 0 to 2 since you're right. So instead of less than or equal to, you should have less than, like that. Mhm. Yes, it would. That would blow up down there too. And now there might be other issues, but that I believe gets around that index out of whatever bounds. You'll probably find it won't ask you to put 4 numbers in. If it does, then there's someplace else we need to. Different issue, but it's not blowing up on the index out of bounds again. Yeah, it looks like you never actually set an array equal to X. Right, like 21, you got to flip it around. Hmm. Now, what would make me think that if I was debugging is the fact they all came up as zeros, and you're inputting the numbers, so the numbers aren't getting to the array. Right. I guess Java must default them as 0. Right. And that's the hardest part. Looking at somebody else's code, because you got your own mind wrapped around how you code, but then looking at somebody else's and then deciphering what they're doing is sometimes a challenge. Hmm. Oh yeah, yeah, that's fine. Okay, where were we? The for each. Someday I'll actually make me posters. I probably couldn't see it from over here, but if I had posters of the main constructs in every programming language I work with, I could just look over on the side and see, oh, okay, yeah, that one doesn't. Yeah, because arrays is kind of the same no matter what language, but everybody defines them differently, and I can never remember. Okay, the for each. This is kind of a shortcut way to loop through. Um, Here's a for the data type, and then your instance, and then colon your collection. This is your collection of objects. So here's a example of what will this code output. You see we got our an array of strings. Then we got them assigned here, and then we got our type here for, and it's a type, and then the this name right here is whatever we want to call it. So that's what we define for the for loop. And then colon names right here refers to the name of our array. So for like this example here, it handles it automatically for us. So it's kind of neat in that way. Um, no, I don't think I've ever done this with like a integer. Not sure if I've ever done with a string. Well, I've tried for an integer after I do look at this. Okay, so if I run that, so I'm curious if it would work for an integer. That's interesting. Lisa Kevin. Oh, yeah, it's written to have a comma there. I was wondering why it wasn't printing the last one, but it printed all three. Now this could be accomplished by the same with the same idea. Doing this for int x equals 0, continue x is less than names dot length x plus plus. And you say system dot out dot print and what's it called? Names x plus comma like that. Something's wrong. Lisa, Kevin, Roger. Oh, for loop within a for loop. There. Lisa, Kevin, Roger, Lisa, Kevin, Roger. So just another way of looping through your array. Works real well when you have like objects, because it's just kind of self documents. So for humans, age, um, and maybe employees or something. Well, this we know is an object, a class. So it defined humans, and within the humans, we got an array of employees. So anyway, that's probably about the only place I really see it of a whole lot of value. Let's see, int. That's not right. Int test equals new int3 2. Test 0 is equal to 5. Test 1 is equal to 7. For int nums, and the rename is test. System dot out dot print nums run that. No red squiggly, so it must be possible. 57 or 5 7, no space in between them. So yeah, just a different way you can loop through it. You don't have to refer to the length. You don't have to refer to the index. It handles that for you automatically. Nums. Yes. Yeah, this is whatever name you want to call it. This has to match the name of your array. You don't have to define the length of the array. You can have it in a method like you were showing, or why I showed earlier. We can have a separate method and then bring it in like that. What will this code output? Would exist, I guess the same thing. Same values. Okay. Why will the following code fail to compile? String names is equal to Lisa. So this is not an array. For string name of names, I think mainly because it's meant to be for arrays, or not arrays. But yeah. Lists of items, I should say. Because up here, this isn't our standard array, is it? But it is a list. So string name is not an array, nor does it implement iterable, so the compiler will throw an exception since it doesn't know how to iterate over the string. I'm guessing that this right here, remember where we'd have a list that you could go through this, since it's iterable, if I'm saying the word right, where you can iterate over the different indexes. So that's what we're referring to. It doesn't have to be necessarily an array. It could be a structure like that. Why will the following fail to compile? Okay, we got a string names equals new string, so we've got an array of strings. Variety name of names. What's wrong there? No, that shouldn't cause an issue. It might print null, might print space, but this is declared as a string, isn't it? And the type we're putting here does not match. Yeah. And maybe there's another reason too. Maybe it'll tell us that failed compile because left hand does not define the instance of string. Okay. Notice in this last example, array is initialized with 3 null pointer values. In and of itself, that will not cause the code not to compile, as a corrected loop would just output null 3 times. So it would be null instead of like a space. Let's see. The for each was introduced in Java 5 as a compile time enhancement. It means that Java actually converts the for each loop into standard for loop during compilation. For example, assuming names is an array of string, as we saw in the first example, following 2 loops are equivalent. So again, it just translates it into the other one. It just makes it easier, a little bit easier maybe to code, is what they're going for. Well, the for each statement is convenient for work with lists in many cases, does not hide access to the loop iterator variable. Want to print only the comma between names, we can convert the example in the standard for loop. Okay. Okay, understand advanced flow control. You can have nested loops. Now this is a multi-dimensional array. This is like if you're programming a matrix. So 3 by 3. So if you're trying to you've never seen a matrix, okay, 3 by 3 matrix might look something like this. Matrix is a rectangular array of numbers. Like that. So 3 rows, 3 columns. Now you can put them all in at once like this, and you don't have to define the size. And then you can have a nested for loop to print off all the rows and columns. Sometimes it's a challenge to print it off when you're doing multi-dimensional arrays. Like if I said A 0 0, I think it's row by column, but it's equal to 1. Row 0, column 1 is then equal to 7. Maybe I will go with a 3 by 3. Too much typing. So 2 by 2. This, in theory, should be 1725. Like that. Now, we've looked at simple arrays. These multidimensional arrays are sometimes the most challenging ones if you're going on for a computer science degree. It's hard to wrap your mind around the operations that should be done. So we've got B here, B, 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 -2, 4, 11, 1. And T, B. Now, if you want to add two matrices together, so if I have two matrices, this one is -2, 4, 11, and 1. So if I put a plus in between there, for those who've had college algebra, how do you add these two matrices together? Add together the corresponding. Exactly. 1 plus -2 is -1. 7 plus 4 is 11, and so forth. Now, that's easy to program. You come down here, and I don't really like the letters they choose. For me, it's easier if I think rows and columns. So int row is equal to 0. Now continue while row is less than 2. You can probably refer to the length of A, but I'm not sure how that'd work. So I'm hard coding it. Oops, not R. Row is less than 2. Row plus plus. So that's going to loop through the rows. And then I'll have for int column is equal to 0. Column is less than 2. Column plus plus. I'm looping through the columns. And then I'm going to add them together, which means I need a new matrix, C, or sum, or whatever. C is equal to new, int 2, 2. And I'm going to say C of row, column, column, or comma, column, is equal to A row, column, plus B row, column. Bracket expected, not a statement, not a statement. Semicolon expected, bracket expected, not a statement. Oh. I wouldn't say I was confused now within the programming language, but I don't do multi-dimensional arrays that much. No, this is 2 dimensions. But you're right, you can do a 3-dimensional array. Now, if I want to print it off, yeah, your three-dimensional array, you just put another bracket on here. And then you have your X, Y, Z. Never have done that before. Never really programmed that deep into math. Okay. We'll print off the array, so steal that. Now I want it to look like an array when it prints off. So when a row changes, I want it to go to the next line. Okay, so I want some braces in here. What in the world? And for here, I want a space after the number. So I want to print C row column plus a space. So for system.out. Then after that row gets done, I want to print a next line. So system.out print line like that. So in theory, when I run that, we get -1, 11. -1, 1 plus -2 is -1. 7 plus 4 is 11. 13, 2 plus 11 is 13. 5 plus 1 is 6. So it's working. Except I didn't put brackets on it. So I could put brackets around it. That's adding matrices. Now that's the easiest one. I knew I could do that. I'm going to try to do multiplication, but I'm not always successful with multiplication. I can hard code it for a 2x2 and have the answer real easy. But that's not the good programming. So what I'm trying to do is multiply these two matrices together. And what you do is you take 1 times -2 plus 7 times 11. So you're taking row 1 of this matrix times column 1 of this matrix. And then you're taking row 1 of the first matrix times column 2 of the second matrix. Then you're taking row 2 of the first matrix times column 1 of the second. So you're taking 2 times -2 plus 5 times 11. And then I'm taking 2 times 4 plus 5 times 1. So when that gets done, that should give me -2 plus 77, 75. 4 plus 7, 11. And -4 plus 55, 51. And 8 plus 5, 13. Assuming I multiplied and everything correctly. I can't see that, but I don't know enough about this package should make it bigger. Or expand it so I can see it down here. But anyway, so let's see how to do that. Looks like I'm looping through my rows. This right here, and that's oftentimes what you have to do is you have to think about it. Like I say, if I may not get this, I don't make no promises on that. This right here would be row 1. This would be row 2. When I say row 1 and I say row 2, I'm talking about what I'm multiplying by the first number here. 1 and 7. 1 and 7. That's row 1. Not the fact that this is on row 1. And then the 2 and 5 and the 2 and 5. That's from row 2 of matrix 1. So it appears like what I'd have to do is loop through my rows. Row equals 0. Continue while row is less than 2. Row plus plus. Now, multiplying this times that, this times that. So for int column equals 0, column less than 2, column plus plus. So for each row here, I'm going to multiply times column 0 and column 1. So that's what that's saying. Okay, we'll come back to that. C something something. I probably need to set C equal to 0 initially. But I'm going to take A, my row, column, I'm still missing something. I think I need another loop in there. How am I going to wrap my mind around that? Now cheat. Hey, let me show you what the code should look like. I could get it, but it would take me the rest of the class, I think. Java multiplying multi-dimensional arrays. So I think I'm supposed to have 4 or 3 for loops in there. Here's a missing one. This code right here, if I put it in there, is how you would multiply them together. C2, C1. Okay, you cheat. Okay, row 1 was our 2. Get that 2. Column 2 is 2. Wonder what's C1. Oh, R shall be 2. Then C would equal to A times B. But C has to be zeroed out initially, or it won't work. Helps if I actually print it though. Print the array again. Seventy-five 11. I don't remember what these two numbers were, but that's what it should be. Yeah, 51, I guess. 55 minus 4. And 8 plus 5, 13. So this is how you would multiply two matrices together. Oh, I can't remember that. Looks like it's just simply I, J, K going from 0 to 1 in both of them. This is the challenging part, getting that right. The reason why you have to have a plus minus here is because when we multiply these together, you add them. So you take negative 2 plus 77. So that's where the adding is coming into there. Anyway, lots of things you can do with these type of loops. For the most part, I'm guessing, Kyle, you'll never have to do much with that. Most of your game engines have a multiplication built in if necessary. Um, I've used a couple of other game engines where the for loop was built in. You didn't have to write your own for loop. Um, Dawson, with game development, your position of a 3D character is kept track of with a matrix. And every move you do in a 3D video game is a matrix multiplication. I suppose if you had a real cryptic game engine that you had to work with, maybe you'd write your own multiplication. Um, but most of them have methods already built in to handle that. They even hide it even more in Unity, which a lot of games are developed on anymore. They've made it so much easier. Okay, anyway. This is talking about putting labels in here. So we got our outer loop and inner loop. Dealing with only one loop, they add no value, but as we see in the next section, they're extremely useful in nested environments. Optional labels are often only used in loop structures. A break. You saw when working with switch statements, break statement transfers the flow of control out to the enclosing statement. Same holds true for whiles, do whiles, and for loops. So if you want to end the looping structure early, you put a break in there. You do an if statement, and then you do a break, and it drops out of the for loop completely, or the while loop, or whatever. No, I don't. I hate them. There is times where you might be challenged to not use it, but in the standard one, yeah. Let's see. It seemed like there was a API call, and I'm not sure if it's in this PowerPoint or not, that had a break in it, and it actually seemed like it was appropriate there. Uh, there are rare occasions where um, maybe you're checking the status of the operating system, like you're checking to see if something's still running, and maybe a break there might be appropriate. So you just want to keep looping, and I think that was in Unity. Do you remember that, Kyle, where we had that break? There was one of the every by the way, Kyle, every call we make in Unity is a API call. So anything that's not your standard C sharp code is calling the API of the game engine. And there was one that had a break in it that really did seem kind of it fit. I'm not even sure how you would have programmed it else otherwise. So it was like wait 1 second and then check to see if whatever's still running, then break if it's done running type of deal. Though you could probably done it another way. I'm not gonna show break because I don't like them. Continue, I don't like either. What continue does is it stops that current iteration and then goes to the next iteration in your while loop. Um, Not completely breaking out of it, just that one iteration. And I suppose if you put the continue in the wrong place, you could easily write an infinite loop. Because if you break out of that iteration before it could actually increase, um, your increment, then and it kept doing that same, yeah. Okay, I'm not gonna look at the continue. This talks about when you can use these, I guess. And again, I don't care about those. That's the end of the chapter. Okay, so chapter 3, core Java APIs. And creating and manipulating strings, we're seeing this. You got your string name equals Fluffy or whatever. You could also do this. String name equals new string, and then Fluffy inside the parentheses like that. It says both give you a reference variable of type name pointing to the string object Fluffy. They're subtly different, as you see in this section. String pool. For now, just remember the string class is special and does not need to be instantiated with new. Remember, new, when you're talking about objects, always creates a new instance. And they're saying you don't have to instantiate it. For concatenation, that's where you take one string and you put it with another string right next to each other. Placing one string before the other string, combine them together is called string concatenation. There aren't a lot of rules to know for this. If both operands are numeric, plus means addition. If both are string, means concatenation. I think if you got a mix, I think it's an error, but maybe I'm wrong. No, it allows you to concatenate them together. Because first one's a string, second one's a string, last one's an integer, and it puts them all together. Other programming languages would give you an error if you try to do that. This appears to do it from left to right, like 1 plus 2 is 3, and then it concatenates it with C. Let's see, 1 plus 2 is 3, plus another integer, which is 3, so that's 6, plus the 4, which should give us 64, I think. Yeah, final answer of 64. Let's see, what's this do? Oh, it starts here. S equal to 1, so it's a string. Plus equals would concatenate it, so that's 12. Plus equals a 3 here would be 12 and then a 3. So 1, 2, 3. Yeah. So that's not too hard on the concatenation. Just remember it's from left to right. Let's put strings or parentheses rather. Once a string object is created, it is not allowed to change. It cannot be made larger, smaller, and you cannot change one of the characters inside it. You can think of a string as a storage box you have perfectly full and whose sides can't bulge. There's no way to add objects, nor can you replace objects without disturbing the entire arrangement. The trade-off for the optimal packing is zero flexibility. Mutable is another word for changeable. Immutable is the opposite, an object that can't be changed once it's created. And on the OCA exam, you need to know that the string is immutable. Drink here. Class mutable takes my private string S, public void set S, string news, S is equal to news, so that sets it. Gets this, returns it. Immutable, private string S equals name. You do a get, and no set. Okay, mutable only has a getter. There's no way to change the value of S, which is set. Mutable has a setter as well. This allows the reference to S to change to a point to a different string later. Note that even though the string class is immutable, it can still be used in a mutable class. Um, what does this print out? Got one. We concatenate S1 dot concatenate 2 should give us 12. Then I'll take 12 and concatenate 3. 1, 2, 3. Ah, I didn't see that. String class is immutable. Did it give you an error? No error. Just doesn't do what you think it would do. So S2 dot concatenate. System dot out dot print line S2. It's happy. So here's a question for you. This S2 right here, concatenate, will not change the value of S2. How come I can change it here? This is always kind of a tricky topic in programming. Um, a lot of programming languages handle with different terms, different concepts, and so forth. Um, is this pointing to the same location in memory? No. It's well, since I'm assigning it a value there, it's like creating a new location for it. We're still using the same variable name, but it's pointing to a different place in memory. And that's what they're talking about. The immutable is when you're looking at the old location of it. And like I say, I don't remember exactly how Java deals with that, but what I've read in some programming languages is a string you don't know how big it's going to be, so it allocates space for it. And since you've allocated this set amount of space, you can't throw 2,000 characters on the end. You have to reallocate space for it, and that's the concept of it. Now C is a little bit different. C is such that when you put a string in there, it puts a /0 on the end. So, but anyway, we'll read shortly. Probably maybe how it talks about the memory. Okay. Strings are everywhere in Java. They use up a lot of memory. In some production applications, they can use 25 to 40% of the memory in an entire program. Java realizes many strings repeat in the program and solve this issue by reusing common ones. The string pool, also known as the intern pool, is a location in the JVM that collects all the strings. I don't think either one of you has used Android Studio, but Android Studio uses Java, and they specifically set the strings to a separate location in order to try to handle the memory better on your cell phone. So you're developing an app for your cell phone, and they got that string pool. It's put over here for a specific reason, for memory. get that to come up while you guys are. Okay. Let's see. Remember back when I said these two lines are subtly different. Former says to use a string pool normally. Second says no JVM. I really want you to use a string pool. Please create a new object for me, even though it's less efficient. When you write programs, you wouldn't want to do this for the exam. You know that it's allowed. String class has dozens of methods. I don't even think I know all the different ones there are. Length is one of them. So if I have a string, S equals David, then system.out.println S dot length. Now notice I had to put the parentheses on it there. It's a method that's defined. That's different than the length of the array. The length of the array did not have parentheses. It's not a method. And so it gives us 5. So string is just an array of characters. So it'll keep going, put an array of characters in your memory until it knows when to stop. See here in Android Studio, they have a specific place where they just put strings. Building upon that concept that strings take up a lot more system resources. I did that in the class the other day. It was sloppily done. I used like a string to whether to continue or it was some kind of flag I used. I don't even remember what it was now. And you're not supposed to use strings. They take up more memory, even though they may look a little bit easier to read. You try to stick with like integers or even smaller ones. Boolean's good. Boolean doesn't take up a whole lot of memory, and that's why people like Booleans for that reason. The character at gets the character at a specific index. David is position 0, 1, 2, 3, 4. So if I want to retrieve the V, I'd retrieve his position 2. So system.out.println s.character at, and let's see, V was 2. So retrieves a V. All these are meant to make your programming easier. Animals, which is 0, 1, 0, 1, 2, 3, 4, 5, 6. So 0 through 6. Character at 0 is A in animals. The character at 6 is S, our last one. And character 7 throws the exception. That's that index out of bounds. Index out of bounds tells you you exceeded the array. Because a string is just an array of characters. Index of usually searches for some kind of substring within a string. Like here, they're searching for where the A is located at. Here, they're searching for where the AL is located. So, for example, here, David, comma, Hayes, comma, 100 Main Street. String S line equals to David Hayes. Let me get rid of the comma, that space there. Hayes, 100 Main Street. This is common when you're working with files. So if you want to retrieve these says separate items, then you need to pick these apart. Now there are some that allow you to split it apart, slice it based upon the parameter. Some programming languages don't have that, so I'm going to show you. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. So first comma is going to equal to, actually just say comma 1, is equal to S line index of, and I'm going to look for my comma. So if I do system.out.println, and meant comma 1, I'm not sure what happened to 1. That should return 5, shouldn't it? It does, returns 5. int comma 2 is equal to S line dot index of. Now we get different overloads here. This string right here, it looks for a string based upon starting at a certain index. So I can look for a comma starting at a certain value. Now, if I don't have that certain value, it's going to find the first one again. It'll keep finding the first one all day long. Now, what do you think I'm going to put as my starting place to start looking? Do I? If I don't want to hard code it, I would put comma 1, and that might do it, but I'm going to put a +1 just to be on the safe side. I'd have to play with that to make sure that was correct. And then like something. Index of. The what? Oh. Comma 2. I'm not sure if there should be comma 1 or comma 2, or comma 1 or comma 1 plus 1. I'm sure that'll work since my commas aren't close to each other. Five and 10. 10 would be my second one here. Question becomes if I had a comma here. Second one should be 6. So let's run this. 6. Okay, so I'm correct with that +1. I figured I was thinking I might would be, but memory's not that great. So then my I guess I don't got any more commas, do I? Now this would help us with a method to split apart our string, substring here. This is going to start at a certain position and allow you to pick off part of your string. And I'm not very good at these, so that's why I put the numbers on there. String, first name, last name, and address. First name is going to equal to S line, and then dot substring. Substring. I'm going to start it at 0, because that's the start of my string, right? The ending index. Well, my ending index ends at 5, but I don't want to hard code 5. But 5 is also ends at 4, doesn't it? So my question is, if I put a 5 in there, would it get the comma or would it just get the D? Now again, I'm not going to put 5. I'm going to put comma 1, because that's the location of the first comma. And let's see what this looks like. Like I say, I'm not very good at these. It always takes me a while to work with strings. We'll see if that gives us David or David comma. David. So work perfect. Now our last name. And I usually just play with these until I do get them right. What do you think it's going to start at without actually putting a number in there? Comma 1? Comma 1. Is that we're looking at Hayes now? It's either going to be comma 1 or comma 1 plus 1. But it doesn't matter. Let's try comma 1. And it's going to go to, where do you think? Comma 2. And I'm guessing this will be a plus 1 since the one up above was a plus 1. Or wait a minute, it wasn't a plus 1, was it? Okay. So let's see what that looks like. System.out, print line. And print last name. Okay, so it looks like we got the comma. We didn't want the comma. So instead of this being comma 1, it should be comma 1 plus 1. Okay, so then our last one. Last one's always a little tricky. Address is equal to S line dot substring. Now, if that was comma 1 plus 1 up above, what do you think this will be? Exactly. Now, here's where it's a little tricky, because you have to take the length. I have to think about this myself. The length of this, length is, it goes up to 25, doesn't it? So length is 26. My last one's going to start at, so like, it's going to start at 10, 11. Start at 11. Yeah. Actually, this is not the length. This is the stopping position, isn't it? So it's not as hard as I'm thinking. I'm overthinking it. So this would be, yeah, this would be your S line dot length. I think it'd be a -1. Because remember, the length would be like 26. I really want to go to 25. 26 would give us that index out of bounds error. System.out, print line, address. If I run that, that's not right. So it looks like +1. I need to go one more, doesn't it? So take out the -1. And that's working. Beauty of this is, besides hard coding to 0, which is a pretty good assumption that's going to start at 0, besides that, we have not hard coded any numbers. So if I come up here and change this to Bill Schmitterstein, 100 Main Street, Bulgaria, Street. Now if I run it, works perfect. I did not change one bit of code. Um, and there's string methods to slice your string apart based upon a parameter, like a comma, a delimiter. That's the word I'm thinking of. Based upon a comma or a pipe symbol or something like that. And we'll talk more about that. We're out of time. Just talk about substring. Okay. Next topic will be 2 lowercase and 2 uppercase. So we'll go ahead and stop there. No assignment again. I'll give you an assignment next time. I'll decide on the final project. I kind of like that tutorial. I always like tutorial ones. I use that a lot. And then as part of that, I think I'll incorporate like maybe files and working with comma separated values. So that's kind of fun. Those are interesting ones.